Hello! Today we're going to have a look at dividing a polynomial by a linear bracket. How I'm going to do that is I'm going to set it out like I would set out a long division sum. So I'm going to write a divide and I'm going to put the thing I'm dividing by at the start. So I'm going to write x minus 2 and I'm going to put the thing I'm dividing under my division. So I'm going to say x cubed. Now I need to be a little bit careful here. There is not an x squared written down, but for my division I need to have it set out with every term there. So what I'm going to do is I'm going to say I have no x squareds, but I'm going to write 0x squared to say I've got no x squareds. Minus 8x plus 6. Then all I'm going to do is I'm going to follow the 4 steps. The first of which is what do I need to multiply x by to get? So I'm going to have a look at my first term, which I'm dividing by, and the first term in the thing I'm dividing. In this case it's x. It might be that you have 2x or something like that. It might be that you end up needing to multiply by a fraction. That's okay, you've just got to be really confident with what you're doing. So what do I need to multiply x by to get x cubed? Well, x times x squared gives me my x cubed. So I'm going to multiply my whole bracket, the whole thing I'm dividing by x squared. And that's my second step. So x squared times x minus 2 gives me x cubed minus 2x squared. And now you can see, because I've been careful with how I've written out my division sum, I have my x squareds under my x squareds. Then I move to my next step, subtract it. Now we've got to be very, very careful with minus signs when we do this. If your division goes wrong, it will be because you've been careless with your minus signs. So when I do my subtraction, I always put brackets in and I always write the subtraction. So I'm always thinking about how many minus signs I've got going on. Then I say I've got x cubed and I take away x cubed. Well, I don't have anything then. I've got 0x squared and I take away minus 2x squared. Well, this minus and this minus become a plus, so it's 0x squared plus 2x squared, which gives me 2x squared. The final step is to go back to my original division and I'm going to bring down whatever is next. So here I've got minus 8x, I'm going to bring it down and I'm going to write minus 8x. And then all I need to do now is just keep repeating those steps. So I ask my first question, what do I need to multiply x by to get? Well, in this case, the thing I'm aiming for is to get 2x squared. So what do I need to multiply x by to get 2x squared? Well, in this case, it's going to be plus 2x. Then I multiply by it, so I'm going to do x minus 2 times 2x. Well, x times 2x is 2x squared. Minus 2 times 2x is minus 4x. Then I subtract it, and again I'm going to be really, really careful with my brackets. 2x squared minus 2x squared is 0. Minus 8x, my minus and my minus make a plus. So minus 8x plus 4x leaves me with just minus 4x. And then I bring down the next term, so I have a look, the next term is plus 6, so I'm going to bring down my plus 6. And I do it one last time. What do I need to multiply x by to get? Well, I'm aiming for minus 4x, I'm starting with x, so I need to multiply by minus 4. I multiply by it, so I'm going to say x minus 2 times minus 4. X times minus 4 is minus 4x. Minus 2 times minus 4 becomes plus 8. Now I subtract. I get minus 4x minus minus 4x. My minuses become a plus. So it's minus 4x plus 4x, which is 0. And then I've got 6 minus 8. So that is minus 2. We've got special words for the parts of the answer. The whole number bit we call the quotient. It might have fractions in, but it's this the bit which is divided exactly. And then the leftover bit, just like in a normal division, is called the remainder. You will often find division of polynomials questions get wrapped up with factor remainder theorem questions. Let's have a look at an exam question. This is an OCR Core 2 exam question from January 2012. It says the cubic polynomial f of x is defined by f of x equals 2x cubed plus 3x squared minus 17x plus 6. And part I says find the remainder when f of x is divided by x minus 3. Now this is much easier once you've done the remainder theorem, but I'm going to use division just to get some extra practice at it. So I'm going to write out my division. Now I've got all my terms there, so I don't need to worry about missing terms. I can just write 2x cubed plus 3x squared minus 17x plus 6. And I'm going to write my x minus 3 at the start. And then I'm just going to keep following my steps. What do I have to times x by to get 2x cubed? I need to times that by 2x squared. And now I times my whole bracket by 2x squared. So I get 2x cubed minus 6x squared. I'm very careful about my signs. I get 3x squared plus 6x squared becomes 9x squared. And then I drop down my minus 17x. I say, what do I need to multiply x by to get 9x squared? Well, that's going to be plus 9x. So I multiply by 9x. That gives me 9x squared minus 27x. And I subtract them. And I'm left with minus 17x plus 27x. Gives me plus 10x, and then I drop down my plus 6. I finally say, what do I need to multiply x by to get 10x? Well, that's going to be plus 10. So now I do x minus 3 times 10. That gives me 10x minus 30. I subtract them, and I will get 6 plus 30 is 36. Now, this is far easier to do once you've done the remainder theorem. Part II says given that f of 2 equals 0, now we've not covered this in this video, it's going to be covered in the factor theorem video, but f of 2 equals 0 means that x minus 2 will divide my polynomial exactly. So express f of x as a product of a linear factor. Well, I'm saying x minus 2 is going to be my linear factor. And then I also need to find a quadratic factor. I'm going to use my information that this tells me that x minus 2 divides exactly. So I'm going to use x minus 2. And then I'm going to write out my 2x cubed plus 3x squared minus 17x plus 6. If you're not given what the linear factor is, you can just have a look at the number on the end. In this case it's plus 6. And we know that it's going to have to divide 6. So you can see that my 2 divides my 6. It could have been a 3, it could have been a 1. But it's going to divide 6 if you're not given it and you need to work it out. Don't try 5, because 5 doesn't divide 6. So I'm going to say, what do I need to multiply x minus 2 by to get 2x cubed? Well, that's going to be 2x squared. So I get 2x cubed minus 4x squared. And I'm going to subtract it, being very careful with my signs, and that's going to give me 7x squared. I drop down my minus 17x. I'll say, what do I need to multiply x minus 2 by to get 7x squared? Well, that's going to be plus 7x. I multiply it, 7x times x is going to be 7x squared. Minus 2 times 7x is minus 14x. I do my subtraction, and this becomes minus 17x plus 14x, or minus 3x, and I drop down my plus 6. What do I need to multiply x by to get minus 3x? Well, that's going to be minus 3. I do my multiplication, so I get minus 3x plus 6. and you can see I'm left with 0. So no remainder, it has divided exactly. So to finish off the question, it says express f of x as a product of a linear factor and a quadratic factor. So just dividing isn't enough. I need to read the question again at the end and make sure I have fully answered the question. My linear factor is going to be x minus 2, and my quadratic factor is just going to be the answer to my division, the quotient, which is 2x squared plus 7x minus 3. We have a final question. Determine the number of real roots of the equation f of x equals 0, giving a reason for your answer. So we got used to, in core 1, thinking if we were asked for the number of roots, it might be a discriminant question. And we've got a quadratic, so it still might be a discriminant question. To work out the number of roots the quadratic has, and I'm going to substitute in my numbers. So 49 minus 4 times a, which is 2, times c, which is minus 3. As always, being extra careful if you see a minus sign, I would always substitute it in brackets. We get 49, well my minus is going to become a plus, so we get 4 times 2 times 3 is plus 24. So my discriminant is equal to 73. As my discriminant is positive, I know that my quadratic has 2 roots. But, as well as the quadratic, I've got my bracket x minus 2, which is going to give me 1 root. So in total, I can say the number of roots is going to be 3 real roots. Other follow-up questions you might be asked would be to fully factorise. So once you get to your quadratic, factorise it again. Solve f of x equals 0. So rather than work out the number of roots, solve the equation. And we know that our first bracket is going to be equal to 0. Or our quadratic's equal to 0, the quadratic might not factorise. It might factorise, in which case you can factorise it. If it doesn't, then you need to use the quadratic formula or complete the square. Finally, it might ask you to sketch a graph showing all the intersections with the axes, in which case you need to solve the equation f of x equals 0 to find the intersections with the x-axis. In this case, it would be intersecting the y-axis at plus 6. And then you have a go at sketching the graph. I hope that's been useful to you looking over division of polynomials.